Okay, in this video we are going to talk a little bit about finding and using unit vectors. So to begin with, there's a couple things that you need to know. So the first thing is you need to really know what component form of a vector is, because I'm going to use that throughout the video. So component form is when you write a vector as just really an ordered pair, and the ordered pair represents a set of directions, and the directions tell you what delta x is going to be and what delta y is going to be. So if delta x is positive, you move to the right. If delta x is negative, you move to the left. And then delta y, same deal. Positive, move up, and negative, move down. So that's component form. We also need to know what the norm of a vector is. So the norm of a vector has its own notation, and it kind of looks like a double absolute value. So we do two vertical lines, then the name of the vector, then two vertical lines. That's going to be equal to the square root of delta x squared plus delta y squared, which looks a lot like the distance formula because it basically is the distance formula. You're finding the distance of the component form, which is really the terminal point of the vector, to the origin, which is 0, 0. So the distance formula reduces down to that. That's how we find the norm. You might also call the norm, because it's another valid name, the magnitude of the vector, or you could also call it the length of the vector. So all three of those words are interchangeable, and you pretty much need to know that each of them means to find this thing. So now we need to know what a unit vector is. A unit vector is a vector that has a magnitude of 1. And to create a vector that has a magnitude of 1, what you want to do is take your original vector, which I call v, and then divide it by its magnitude. So if the original vector had a magnitude of 12, and you divide by 12, now you have a vector with a magnitude of 1. So that looks like v over the magnitude, or the norm, or the length of v. And there's actually another way to write them. I'm not going to really use it in this video, but you should be aware that another way to write it is cosine theta comma sine theta, but then you need to know what theta is. Theta is the direction angle for the vector. So I'm not going to use that in this video, but it's definitely a thing, and it's definitely an important thing. Now I'm going to do a couple of examples. So the first one, I'm just going to give you a vector in component form, and we're going to turn it into a unit vector. So the vector is negative 3, 5. So negative 3, 5, first I'm going to find the norm. So that's using proper notation. It looks like that. It's going to be the square root of the quantity negative 3 squared plus the quantity 5 squared, which is 9 plus 25, so radical 34. And then to create a unit vector, we take the vector, so it's going to be v, divided by its magnitude. And that's going to be equal to, so what I'm going to do is I'm going to actually distribute the magnitude in, or 1 over the magnitude. So I'm going to end up with negative 3 over radical 34, comma 5 over radical 34. You could check and see that the magnitude of this vector is 1, but it's definitely going to be 1 if you work it out, because in the numerators you get 3 squared and 5 squared, and then they're both over 34, so add those, you definitely get 1. Let's take a look at another example, which is like one step up from this. So instead of being given component form, I'm just given the initial point and the terminal point, and I'm told that I want to find a unit vector that's going to go, a unit vector of the vector AB. So A is initial, B is terminal. So I need to actually calculate the vector AB before I can actually do the problem. So that's going to be terminal minus initial. So the vector AB is going to be 6 minus negative 2, comma, negative 2 minus 5. So that simplifies to 8, comma, negative 7. So now I need to find the norm of this vector, because that's what you're going to do pretty much every time unit vectors come up. So it's going to be the square root of 8 squared plus 7 squared, which is the square root of 64 plus 49, which is the square root of 113. All right, so we have the vector in component form, we have the norm of the vector, so we're going to divide those and get a unit vector. And that'll give us 8 over radical 113, negative 7 over radical 113. You might notice that I don't rationalize these. You don't really gain much by rationalizing them. If your teacher wants you to, then definitely do that. But I find it easier to not rationalize them, because you kind of can look at it and then see the norm of the vector. You do a lot of things with them where you actually factor out the norm of the vector anyway, of the original vector. So I like to not rationalize, but up to you. Let's take a look at one more example. So in this example, we know the vector w is parallel to -4, -1. We know the magnitude of w is supposed to be 16, and we want to just find w. So before we do this, we need to remember one fact about parallel vectors. So a is parallel to b if and only if a is some scalar multiple of b, and that's going to be important because if we can take this vector and turn it into a unit vector, then we can take the unit vector and just multiply it by the magnitude that we want, and we'll end up with a vector that we want, the vector w. So that's what we're going to do. So let's turn that into a unit vector. To do that, I need the norm. That's the first step in every one of these problems. So just go through the process. So this will give you square root of 17. And now we create the unit vector. So we take -4, -1, and we divide it by its magnitude. So that'll look like this. Probably should have just named that vector. It would have made life a little easier. You'll actually find that to be true a lot with vectors. If you give them names and work with the names, and then at the final step kind of go back to the numbers, life is just simpler, but whatever, we didn't do it. Okay, so we have this unit vector. This unit vector is parallel to w, which means that if I turn w into a unit vector, I'd actually get this. So this thing is the same as w over the magnitude of w. And from there, that's actually an equation that I can use. So I can multiply both sides by the magnitude of w. So the magnitude of w times this unit vector that we found is equal to w. And we know the magnitude of w. It's given, it's 16. So let's just kind of write that out. And then distribute. And we get -64 over radical 17 and -16 over radical 17. So that's the vector w that we're looking for. All right, there's only one more thing I want to tell you about. I mean, I mentioned casually before that we know the magnitude or the norm of a unit vector is 1. That's kind of the whole point of them. And I mentioned there's another way to write this. So since the magnitude is 1, we actually know that the terminal point of every unit vector falls on the unit circle. And since that's the case, we can look at the terminal point as actually just the cosine and sine of whatever angle is formed with the positive x-axis. So we get this, we can get this. We do kind of a weird thing with vectors where we restrict the angle to be from -pi to pi. So the next two angles that I draw are going to be negative angles. So we can go this way to get theta, and we can go all the way there to get theta. And since all of these ordered pairs around the unit circle, they could all be the terminal points of unit vectors. So another way to write our unit vector is just cosine and sine of the direction angle. All right, so that's a bunch of stuff about unit vectors. I hope you found this helpful, and good luck with that.